Hi dears, today we can see some questions related to ODE and PDE for both set and net exam. So the first question is the equation x u x x minus y u y y plus 1 by 2 ux minus uy is hyperbolic in which of the domain? So the general equation we have as a u x x plus b u x y plus c u y y etc. is equal to 0. The major condition is b square minus 4ac. If it is equal to 0, parabolic, greater than 0, hyperbolic, and less than 0 is elliptic. So for this given question, you can see that the value of a is equal to x, uxy is absent, so that b equal to 0, and here c value whose coefficient is minus y. So the condition b square minus 4ac, apply these values, you will get 4xy. Again, in the question it is given hyperbolic. So for the hyperbolic, this value is greater than 0. So that 4xy is greater than, 4xy is greater than 0. So that xy is greater than 0. You have two possibilities that x is greater than 0 and y is greater than 0, so that xy is greater than 0. Not only that, the second possibility is x less than 0 and y less than 0, it also xy is greater than 0. Since this is the one word question, you can see, so we used that the condition xy is greater than 0. You can listen here. So out of 4 options, xy is greater than 0, you can choose it. Clear? Now we can see the second question. The solution of the initial value problem d square y divided by dx square minus 2 dy by dx minus 3y is equal to 2 e power x minus 10 sin x. Okay, 10 sin x. Y of 0 equal to 2 and y dash of 0 is equal to 4 is what this. So usually we will do that m square minus 2m minus 3 is equal to 0. We will do the auxiliary equation, so on so on. That also one of the find method. Here I used options method, that is trial method. Okay, trial and error method, check by options. So what I am used to do is, here the solution is given. Okay, y. So just I am finding that y of 0 is equal to 2 or not. So y of 0 is equal to, in the place of x I am substituting the 0 value and checking whether I am getting 2. So by calculating this one, I definitely say that this is not equal to 2. And doing the second option, there also y of 0, that is in the place of x substituting that values. So there also I couldn't find the value is equal to 2. But in the C option, you can see that you are getting 2. That is y of 0 is equal to 2. We are getting. So option C is the right answer. And for the D also you shouldn't be. So this is the way we can find this. And then the third question, the order and degree of the differential equation 1 plus 3 dy by dx, the whole power 2 by 3 is 4 d cube y divided by dx cube is. So for finding the order and degree, this type of rational should not be there. So cube on both sides so that you will get square, and here cube the whole cube. Okay. So the whole square, a plus b the whole square, expand this one, is equal to 4 into. So order means you have to do the highest derivatives you have to see. Okay, highest derivative, that is the order. So degree means highest derivatives whose degree you have to take, that is the degree. So here the highest derivative, you can see two types of derivatives are there. So this is the highest derivative. So the order is 3 and the degree is 3. So the answer here 3, 3. Then we can see the next question. The differential equation by eliminating arbitrary constants d from y is equal to d into x minus d the whole square is. So you can do this as y dash, you can find, then y dash square you can say, then from eliminating the constants you can do the so many types are there. I used here trial method. So I need to find y dash. Yes, then you have to multiply here. So here you can see y is equal to d x minus d the whole square, y dash is equal to, because I need y dash in the answer. So d 2x minus d, then y dash square is equal to. So by checking options, the first option, y dash square minus 4xy y dash plus 8y, just substituting the value of y dash y here, then you have to take the common value outside. You can find, so the value is not equal to 0. So option A is not right. Now I am moving to the second option. There also you can find, so after taking the common, then the no cancellation is there. From that we can conclude that this is not equal to 0. Then similarly you have to do the C option, and now I am moved to the D option. Here also I am substitute the value of y dash y, and here you can analyze that d minus x plus x minus d. So this get cancelled, which is equal to 0. So D is the correct option. So this is the solution for the given problem. Okay. Now we can see the fourth question. Which of the following differential equation is a linear? So linear, the condition is if the power of y and its derivative is 1, then we can say linear. Power of y and its derivatives is 1. For example, y whose power is 1 and y dash whose power is also 1, then we can together with there could not have any product of dependent variable and its derivatives. Okay, that means you can say y dash. Such type is also should not be there. If it's so, you can say that is the linear case. Okay, so two conditions is there. First condition, the power of y and y dash, not y dash, it is y double dash or y triple dash, whatever may be. Okay, this and its derivatives, or y triple dash, whatever the question, whose derivatives, whose power is 1, and the second option, there should not be this type of category, that is the product of dependent variable and the derivative should not be there. Okay, if it's so, then we can say that that is linear case. So the first one, you can see that y and its derivative is not 1 because it is square, so that the first option is not right. Now you can see the second option, y triple dash. There should not be this type of category, but here it is exist, so this is not possible. Now here you can see that 2y, then y dash. You can see that y whose power is 1, y dash whose power is 1, but together with we have e power xy. So here you can see, yes, e power xy is written as 1 plus xy by 1 factorial plus etc. into y dash plus 2y. So just multiply this one, y dash plus xy, y dash, then x, y square, y dash, etc. So here you can exist that product. So product exists means we can say that this is not linear. Okay. Now I am moving to the fourth option, x power 10 y double dash plus log x plus tan x the whole square divided by this one, y dash plus y is equal to f of x. Here you can see that dependent variable and derivative should not be there. Okay, but here we have just x, that is independent variable whose product can be exist, no problem. But this is not be happen. There is dependent and the derivative should not be exist. If I am taking the LCM means also there should not be any y term except this one. Here also if I take the LCM means also there should not be any dependent variable other than this x. So that here the power is 1. Here the power is 1, again y whose power is 1. So that I can say that this equation is the linear equation, linear differential equation. So thank you.